Hey everyone, Josh the Iron Dad here, and today I've got something really cool to show you. The brand new Creality SpacePi X4 filament dryer. If you're serious about multicolor printing or dealing with moisture sensitive materials, this dryer is a total game changer. Huge shout out to Creality for giving me the opportunity to beta test this unit, and a quick thanks to Aurora Prints for inspiring some of my testing methods. Now, before we jump into testing, here's a quick rundown of some of its features. First, the massive drying chamber, capable of holding up to 4 spools of standard 1 kilogram filament or even larger 2 kilogram spools. Inside, the SpacePi X4 features dual independent heating chambers, each powered by a 200-watt PTC heater, allowing you to dry different filament types at different temperatures simultaneously. It uses active dehumidification with a 4-fan system, 2 exhaust fans to purge moisture, and 2 blowers underneath for full 360-degree hot air circulation, ensuring even, thorough drying across every spool. The upgraded Space Dry 4.0 patented technology intelligently balances efficient heating with energy-saving modes, automatically regenerating the desiccant so there's no manual replacement needed. Control is easy with the new 3.2-inch eDry user interface touchscreen, giving you smooth, intuitive access to temperature settings, timers, and auto modes for storage after drying. Once your filament reaches the target drying temperature, the unit shifts into auto silent mode, reducing fan speed and operating almost silently. Perfect for office or home setups. And for peace of mind, the X4 is equipped with triple safety protection, including smart self-checks, temperature cutoffs, and fan monitoring to keep your prints and your workspace safe. All of this is wrapped in a durable, flame-retardant enclosure with thoughtful features like sliding locks, a moisture-proof seal, and a new rear vent system to expel humidity efficiently. And that space gray looks perfect next to the K2 Pluses. Now, let's put the X4 through some Iron Dad events, starting with the swim leg.
So before we start drying with the X4, we got to make sure that our filament is nice and moist. So what we're going to do is we're going to take this here container, we're going to fill it with some jelly beads, some water obviously, right? And we're going to throw our filament in there and wait a little while. So pretty simple, okay? There we go. It's like little eggs. Alright. I don't know, do we do another one? I guess so. Okay, now we sit this here and wait a little bit.
The jelly beads help simulate a high humidity environment without having standing water that could damage the filament directly. Once those were hydroloaded, I prepped the chamber by placing small pre-cut strips of filament, one for each material. Creality's Hyper PLA, Hyper PETG, the Hyper TPU, Hyper ASA, and Creality's new PPA carbon fiber. The idea here was to supercharge the moisture exposure over several days to see how badly the filament would degrade under extreme conditions.
Several days later.
When I checked the chamber after nearly a week, the beads were fully expanded and the humidity had climbed to 99%. At that point, I knew the filaments were fully saturated and ready for testing. Let's see what happens when you try printing with filament that's been absolutely soaked. First up, PLA and PETG. In their hydro-loaded state, both were stringy with visible ringing and tiny craters from what I call moisture explosions. After drying in the SpacePi, they printed beautifully. No stringing, smooth layers, and only minor imperfections that a few slicer tweaks could easily clean up. Next was TPU, and this one became a saga. The wet TPU was almost unrecognizable. Bubbles, layer skips, weird zones of failure. I'm honestly shocked the print completed at all. Drying it made a world of difference. The final print was nearly crystal clear, with minimal VSAs. There's still a lot of ringing, but that's more of a K2 limitation. TPU isn't exactly its best friend. ASA was next, and wow. The moisture-loaded print looked like it rolled through dog hair and got caught in a sandstorm, stringing everywhere, pinheads, and even layer separation. But the dried print? Mwah! Chef's kiss. It printed flawlessly. No stringing, no ringing, just crisp, clean lines and solid extrusion. It came out looking the best of the entire group. Finally, PPA carbon fiber. The first print was so brittle, I could barely get it off the bed without it crumbling. It looked like a geological fossil with all the pitting and layer gaps. I dried it for 16 hours at 85 degrees Celsius and it got better, but not Iron Dad better. So I threw it in for another 16 hours and that version turned out pretty dang nice. Still, I'd only rate it a B+ because I know it would benefit from drying at 100 to 120 degrees Celsius, which this dryer can't hit yet, but considering the limits, it still impressed me. Overall, I am blown away. The SpacePi X4 has exceeded my expectations in performance, consistency, and just how easy it made filament recovery, especially for materials that are notorious for soaking up moisture. I didn't expect it to be this good, but here we are. Wrap things up, I ran 2 final tests to push the SpacePi X4's performance even further. One at the drying temp of 55 degrees Celsius and another at the maximum 85 degrees Celsius. For the 55 degrees Celsius test, wattage briefly spiked to nearly 800 watts, then dropped to a range between 400 and 600 for about 30 seconds. From there, it hovered at 300 to 400 watts until hitting 50 degrees Celsius, and finally stabilized between 140 and 220 watts at target temp. Sound levels held at 57 decibels during warm-up, dipping to 55, 56 decibels at temp, and dropped as low as 53 decibels once auto silent mode activated. My temp probes tracked within 1 to 5 degrees Celsius of the display, slightly hotter, which I'm totally fine with. At 85 degrees Celsius, both chambers ran hot and steady. After the initial spike, wattage stayed in the 300 to 400 range, with brief peaks to 500, then dropped to a range of 140 and 190 watts once it hit full temp. Sound held around 54 decibels during the climb, then dipped to 53 decibels at temp, quieter than my water-cooled PC. Overall, efficient power draw, consistent heat, and whisper quiet performance. I'll take that any day. Both chambers actually reached full temperature well under the times listed on Creality's website, 55 degrees Celsius in under 5 minutes versus the expected 6.5, and 85 degrees Celsius in just 12 minutes compared to their 20-minute estimate. Now that speed may be helped by the fact that no filament was loaded, but either way, it shows that the 360-degree heat circulation in the SpacePi X4 is definitely doing its job. That's it for my deep dive into the Creality SpacePi X4. Huge thanks again to Creality for letting me beta test this unit. And thanks to all of you for coming along for the ride. If you found this helpful, hit that like button, leave a comment with any questions, and subscribe if you want to see more 3D printing content coming soon. Until next time, stay creative, stay curious, and keep on making.